Well, grade 12s, in this lesson we continue with determining equations of tangents to curves, and what I want to do is I want to focus on a hyperbola, and then the second example will involve a cubic graph, and we're going to find the equation of a tangent to that specific graph at a given point. Now suppose I gave you a hyperbola from grade 10 days, and I said to you, sketch this graph, but remember we're going to choose positive values of x. Okay, we're going to just select positive values of x, and I want you to find the equation of the tangent at x equals 1. Okay, well let's draw this graph and see what we get. Okay, well if you remember, we're going to choose only positive values of x, so I could choose x as, let's say, 1. I'm not going to choose 0 here because 9 over 0 is undefined, but if I choose 1 and I could choose x as 3 and let's say 9. So what would the y value be? Well, 9 over 1 is 9, 9 over 3 is 3, and 9 over 9 is 1. So we can draw the graph now by simply getting a set of axes. Here we go, and we can then quite easily put into place the points here. Okay, here we go. Well, let's say 1, 9 should be about here. Let's put 1 and 9 over here. And then we've got 3, 3 should be about there. And then 9, 1 there. It doesn't have to be to scale, but that's your graph of your hyperbola. Okay, now once you've got that, those 3 points there, remember this is 9, 1 here, and that's 3, 3 there. Okay. Now what I want to do is I want to find the equation of the tangent to this hyperbola at that point where x is equal to 1. Okay, so where x is equal to 1, what's very interesting, we already have the y value there. We've worked it out. There's x is 1, y is 9. So we've got the y of t, we've got the x of t, which is rather great. And we've got a hyperbola for x is positive, and we've got an x value, and we've got our y, and we want the gradient of the tangent to this hyperbola, and then we can get the equation of the tangent. Okay, so how do we get the gradient of that tangent? How do we get that? Well, we're going to have to differentiate the equation of the hyperbola and take it from there. So let's have a look. What have we got? Y is equal to 9 over x. Now remember, with normal calculus, normal derivatives, you bring that x up. Okay, so that's x to the 1, so you bring it up. So how do we get the gradient? The gradient of the tangent is dy over dx, okay, which is going to then equal negative 9x to the minus 2 if you subtract 1 from the original exponent there. If you wanted to use fx is equal to 9 over x, then what you would have done is you would have said fx is equal to 9x to the minus 1, and you would have gone f prime x is equal to negative 9x to the negative 2. But if you use y, of course, we then use dy over dx. So there we've got it there. That's the gradient. And if you want to tidy that up, it's negative 9 divided by x squared. Okay, now at x equals 1, what would be the gradient? What would be f prime 1, or dy dx at that point? Would be negative 9 over 1 squared if you plug in, which of course is negative 9. That's the gradient there, negative 9, because 1 squared is 1 and 9 over 1 is 9. Okay, so we've got the gradient now. So we've got the x of the point of tangency is 1, the y value was 9, and the gradient of the tangent is negative 9. So that's great. So once we've got all of this information here, we can now work out the equation of the tangent line by using y minus yt is equal to the gradient of the tangent x minus xt. Okay, the y of t is 9, so let's plug in 9. The gradient is negative 9 x minus 1. There we go. With a hyperbola, you do this exact same thing, but you do this thing. So it's important you do it exactly what you do with other curves. It's really simple. Multiply this out, and there we have y is equal to negative 9x, and then we've got plus 18 if you bring negative 9 across. That's your equation of the tangent to that curve. Okay, what about a cubic graph? Let's have a look at that. Okay, so here's our second example, and I want you to have a look at this. I want you to determine the equation of the tangent to this cubic graph. Okay, we have drawn this previously, so we've already seen what that graph looks like, and we want to find the equation of the tangent at x equals -2. Okay, what I'm going to suggest we do is let's sketch the graph of fx. It's good practice anyway. We've done it before, but let's draw the graph of this function, this cubic function. Okay, we've already done it, so it's not a problem. We did it in a previous lesson, the exact same cubic, but let's do it anyway. It's good revision, and then we can find the equation of the tangent at -2. So what would be the y-intercept? Well, it's where x is 0, so it's x is 0, y is -4. There we go, the number on the end there. The x-intercepts, well, if we let y be 0, have a look at this. We put the equation equal to 0, divide throughout by 2, as we did previously, and we then going to factorize using the factor theorem. Well, what are the possible factors of 2? Plus minus 1, plus minus 2, and then we're going to test which ones work, which of these are actual answers. When you deal with that. Okay, and if we take a specific value, let's try x equals -1. I don't think 1 will work, but let's try -1. That will be a cube there, by the way. Just be careful, it's a cubed. I wrote it as a squared, should be a cubed. Okay, no problem. So what's that? -1 cubed minus 3 times -1 minus 2, which is -1 plus 3 minus 2, which is 0. Great. So we've got an answer, a solution there. So what do we do for x-intercepts? Let y be 0, and 0 equals 2x cubed minus 6x minus 4. Divide throughout by 2, and don't make the same mistake as I did. So many matrics, they forget, they get caught in the trinomial trap, I call it, and they just want to write x squared. So like I made a mistake there, be careful, make sure it's cubed. It's not a normal trinomial. Okay, now if we look at this, we can bring that across. So we've got x plus 1 is equal to 0, and this guy is one of your factors. So let's write the cubic down. X cubed plus 0x squared, don't forget the 0x squared, minus 3x minus 2, and we then put that equal to 0. Okay, now we've got a factor there, x plus 1. So how do we get the trinomial in the second bracket? We say, well, x cubed over x is x squared, and remember we've got a missing middle term there, and then -2 over 1 is -2, and that's important to check. It's x cubed, the first terms, and then the last term here would be 1 times -2, -2, and we connect the x squared terms with our little smiley face there. So what is that? 1x squared plus mx squared is equal to 0x squared. Remember, there's no term in x squared, so we just write 0. So 1 plus m is equal to 0, and m, of course, is -1 if you solve. Let's plug back and get our x-intercept. So we've got x plus 1 into x squared minus 1x minus 2 is equal to 0. And this should factorize fairly easily. Let's see, it's x minus 2 and x plus 1. There we go. So your x-intercepts will be -1 where it's repeated, or x is equal to 2. So there's our x-intercepts, and we're gonna draw those in a moment. Okay, what about the stationary points or the turning points? Well, let's see. We've got fx is equal to 2x cubed minus 6x minus 4. Let's get the derivative, the gradient. Okay, differentiate, bring the 3 down. It's 6x squared minus 6 minus 0. And at a turning point, the gradient is 0. And we've got a pretty nice little equation here. Divide everybody by 6, and you've got x squared minus 1 is equal to 0. So then 1 is equal to x squared. And remember, plus minus the square root of 1 is equal to x. Then all we have to do is get the corresponding y values. The f of 1, go back to the original. What's the original? There it is there, 2x cubed. So it's 2x cubed minus 6x minus 4. So what's that? 2 minus 6 is -4. It'll cut at -8. So it won't cut, but it'll be a turning point at x is 1 and -8 there. Okay. And then what about f of -1? Well, I'm almost certain you're going to know what that is. That's going to be 0. But let's plug it in anyway and see what we get. There we go, and that gives us negative 2 plus 6 minus 4, which is 0. So there's a turning point at that repeated x-intercept. Okay, and we're going to now we're going to put all this information onto a set of axes and draw the graph. And then we're going to find the equation of the tangent at x equals minus 2. Okay, I've drawn the picture here. I've got the cubic, its x-intercepts, turning points, and what I want to do is I want to find the equation of the pink tangent at x equals minus 2. So what do we know? We've got the x of the point of tangent c is negative 2. We need the y of t, and we need the gradient of the tangent. Well, how do we get the y of t? Well, the y of t is actually going to be the f at negative 2. So let's plug into the original, and that original is 2 times negative 2 cubed. And then it's going to be, let's see, negative, where are we there? Negative 2, what's it? Minus 6x, there we go. Lost a bit of track of my equation there. Okay, so that gives you negative 16 plus 12 minus 4. And that comes to negative 8 there. Okay, because what's that? Negative 16 plus 12, negative 4 minus 4 is minus 8. So great, we've got that sorted there. The y of t is we've got. Now we just need the gradient. So let's get the derivative. So if we differentiate that, f of x is 2x cubed minus 6x minus 4. The derivative is going to be 6x squared minus 6. And what is the gradient at negative 2? Well, there it is, x is negative 2. The gradient of the tangent would be simply 6 times negative 2 squared minus 6. So that's 6 times 4, which is 24 minus 6. And that, of course, will give us 18. Okay, good. So we've got our little gradient of the tangent there. And all we now need to say is y minus the y value, which is negative 8. The y of t is negative 8. The x of t we've already got is negative 2. So we can, and the m we've got is 18. So it's 18x minus negative 2. Okay, and then we simply say y plus 8 is 18x plus 2. There we go, and off we go. So y plus 8 is equal to 18x plus 36. If you multiply out, so y would be 18x, and 36 minus 8 is 28 there. And there's your equation of the tangent.